Here we are given the first four terms of a sequence and asked to find its nth or general term. And so first of all, we will have n equals 1, 2, 3, 4, etc. And our a sub n in the first case is negative 1/5. In the second case is positive 1 over 25. The third term is negative 1 over 125, and the fourth positive 1 over 625. We see that we have the sign of the terms alternating, and when the number of the term is odd, the term itself is negative. In order to do that, part of our a sub n will be a power of negative 1. And if the power of negative 1 is n, then the first term will be negative. The second would be positive because negative 1 squared would be positive 1. Similarly, the third one would be negative because negative 1 to the third would be negative. Negative 1 to the fourth would be positive, so the fourth term would be positive. So part of our nth term is going to be that factor, negative 1 to the n. The other part is going to be a fraction, which always seems to have a numerator of 1 and a denominator which is a power of 5. And notice that it starts out 5 to the first. The second term is 5 squared, the third is 5 cubed, and the fourth is 5 to the fourth in the denominator. So we can write the nth term either as negative 1 to the nth power times 1 over 5 to the n, or you could write it as the fraction negative 1 to the nth divided by 5 to the n, or you could even write it as negative 1/5 to the n. So the nth term does not have a unique representation. It is correct if when you plug in the values for n, you get the terms that were given. So let's try then the next one. Find the nth term or general term of the sequence for which the first four terms are 5/6, 6/7, 7/8, and 8/9. Well, these go with terms that have n equal 1, 2, 3, and 4. And they're all fractions. So what I notice is that the numerator of the first term is 5, the second is 6, then 7, then 8. And so I see that each time the numerators are getting bigger, and that's the same as what's happening to the n. So when n is 1, instead of seeing the 5 right away, what I think I will do is think about the 5/6 as being 4 plus 1 all over 5 plus 1. For the 6/7, it would be 4 plus 2 over 5 plus 2. For the 7/8, 4 plus 3 over 5 plus 3. And for the 8/9, 4 plus 4 over 5 plus 4. So this is for n equals 1, 2, 3, and 4. So in general, I would see that one of the representations of the general term would be the quotient of 4 plus n over 5 plus n. Now there may be others. This is the one that I happen to see first.